calculating the volume of a solid. Suppose you want to know what is the volume of this loaf of bread. One way is to slice this up into smaller pieces and then find the small volume, add them all together, and you get the total volume. Another case, suppose you have this watermelon and you're interested in knowing what is the volume of this watermelon. You can slice this up and then find a cross section, which is basically calculating each volume and then adding them together. But the area of each cross section, the definite integral, gives us the total volume. In general, when we are applying the slicing method, we assume that you have a solid object which extends from A to B on x-axis. Suppose the cross-section of this solid is perpendicular to x-axis and it has an area given by a function like A, which is integrable on closed interval A to B. Then the volume of the solid is the definite integral of A of x dx. So all you need to do is to find the cross-section and calculate the definite integral of the area of that cross-section with respect to x as x extends between A to B. Let R be the region in the first quadrant bounded by coordinate axes and the curve y equals to 1 minus x squared. A solid has a base R and cross-section through the solid perpendicular to the base and parallel to y-axis. They are all squares. Question says, now find the volume of the solid. So basically, what do we have here? Y equals to 1 minus x squared. So as you can see, here you have a parabola which opens downward, but since it's in the first quadrant, x and y are both positive. And please note that the cross-section through the solid is perpendicular to the base and parallel to y-axis, and they are all squares. So basically, you can think about the slice as a square this way. Please note that one side is located on the graph, which is y value is 1 minus x squared. And since question says, hey, it is a square, it means that all sides are equal to each other. So when this side is 1 minus x squared, this side also is 1 minus x squared, that you can basically see here. This is a square slice. Here you have the base of the solid, and the cross-section is in square form. Well, remember the formula. The formula says the volume is the definite integral of A of x dx, and A of x is the area of the square. X ranges between 0 to 1. When you set 1 minus x squared equal to 0, x becomes 1 and negative 1. But because it is in the first quadrant, we stop at positive 1, and the starting value is 0. It doesn't go to negative 1. So this is the integral of 1 minus x squared times 1 minus x squared. Remember that here we need to have the area. The area of this square is 1 minus x squared times 1 minus x squared, which we write as 1 minus x squared to the second power. Now, let us write this in expanded form. This becomes the definite integral 0 to 1 of 1 minus 2x squared plus x to the fourth dx. We're basically just going back to algebra and write 1 minus x squared to the second power in expanded form. These in turns can be written as x minus 2/3 x cubed plus 1/5 x to the fifth. Remember, we can use the integral of u to power n du, which is u to power n plus 1 over n plus 1 plus c. The integral of 1 dx is x. The integral of negative 2x squared is negative 2/3 x cubed. And the integral of x to the fourth is 1/5 x to the fifth. Now, you're going to find the definite integral when x is equal to 0 and x is equal to 1. Basically, if you plug in 0, it gives you 0. So you just need to plug in 1. You get 1 minus 2/3 plus 1/5, which in turn is equal to 8 over 15. So the volume of this region bounded in the first quadrant and bounded by the coordinate axis and the curve y equals to 1 minus x squared is 8 over 15.